So I just want to say we probably all are on a post-land crash. So I thank you everyone for joining me on this presentation. Today we're going to talk about theming solutions for web applications. First, we're going to see how the framework actually manages the theming solutions for its widgets. And then we are also going to see how you can build your own theming solutions for your own custom widgets. So hi everyone, my name is Mauricio Miguez. I'm joining you today all the way from Montevideo, Uruguay. I have been a Flutter developer for a little bit over 4 years. I'm currently a senior engineer at Very Good Ventures. And later after this talk, or whenever you have the time, please come by our booth that is located over there. It's booth 4. We also have some awesome after party after the event, so feel free to join us. You have the details there at the booth. So let's get this started. What is theming? Basically, theming allows us as developer to define the visual identity of our application. It also allows us to define the stylistic members of our app. This means colors, this means typography, this means border radius, and other elements. What it doesn't do, it doesn't touch on functionality. This allows for a clear separation between how our components look and how our components behave. It also is a way to centralize our stylistic members. Instead of having hard-coded values throughout our widgets, we just define them once and reuse them across our application. More than just a cosmetic choice, it's a foundational aspect of app development. It allows us as developer to have an intuitive user experience and have visual harmony throughout our application. So let's now take a look at this basic component. It's just a button. It is actually visually appealing. And if you take a closer look, you'll see that whenever we press it, it will show a snack bar. So we have these two aspects of our elements at play. We have the looks and we also have the behavior. So let's strip things back a little. We have a component that is quite basic now. It's just a plain text. There is no fancy styling whatsoever. However, if you still press it, it will show the same snack bar. So it has the same core functionality, but without the actual visual appeal. So this button is actually has behavior, even though it's not trying to impress anyone. On the opposite extreme, on the opposite end, we have actually meticulously styled widget. It has a rich foreground color, it has generous padding, it has a crisp text, and it also has a subtle elevation. But then if you click it, nothing happens. This shows how styles can exist separate from the behavior of our widgets. You can put a lot of effort into looking it perfect and making it look visually appealing, but if you don't define what the interactions are and what it do, you basically end up with a static element on your UI. When we talk about theming, we refer to defining and applying a consistent look to our UI component, allowing our behavior to be independent from our style. Let's take a look, for example, at web development. On web development, we have two clear languages, and this allows for a clear separation of these two concerns, looks and behavior. We have HTML that is used for the behavior of our components. And then you have CSS that is used just for styling. And generally, you don't mix the two. So having different languages allows for a clear separation of concerns. The problem is that in Flutter, we have one single language across the board, which is called Dart. So this gives us a lot of flexibility, prevent us from mixing these two concerns. Nothing tells you that you can't inline your widgets, but there is a much cleaner alternative, that is to use the Flutter theming system. And this will prevent us to making the common mistake of mixing our behavior with our styles in our widgets. So for setting the stage of any Flutter application, we have two main widgets. They are called Material App and Cupertino App. Cupertino is based on HIG, which is Human Interface Guidelines, which is a design language developed by Apple. And then we have a material theme that is actually based on material design. They both come equipped with a theme property and a class you can modify to style them. The thing is that Cupertino app, even though it is customizable, it is so to a limited extent, meaning you can just modify some stuff like text, colors, and brightness. On the other opposite extreme, we have the Material app that is much more flexible, and it allows to cater for various visual design needs. So for all of those reasons, I'm going to stick to Material Design during this presentation, as it is highly customizable and you can basically make it look like anything you want. So Material app has a powerful and yet opinionated way to style our application and our widgets. It has a theme data class that allows us to define the visual characteristics of our app and applies this theme to the descendant widgets in the widget tree. If you see here, I have a counter application, a basic counter app, which has a slightly modified version of the dark theme. I also have at the right, you have the widget tree of the app, a simplified version actually. And I have outlined some relevant aspects of the theme. For example, you see like primary container and on primary container colors and how those are actually styling the floating action button and the icon inside it. Then we have inverse primary color and title large style, and both of those are styling the app bar and the title. And then we have headline medium and body medium, both styling the text that you see at the middle of the screen that are wrapped inside a column. But how do you actually set the theme for our application? So this involves playing around with the theme data object, which has various sub-themes that govern different aspects of our styles in our application. And we use that to style different aspects of our design system. Our first stop is at the color scheme. It's basically a set of 45 different colors that are defined by a material design language. I will recommend you to create a custom class, in this case, what I call app colors, and use that to style our theme data, in this case, the color scheme. This way it's much easier to centralize our changes in one single file, and you can also set your name of variables to be the same as you have in your theming system. So instead of inline styling your widgets with colors that are static values, you would access the theme data and the color scheme and use those values instead. Then our second stop is at the text theme. As well as the color scheme, this allows us to modify some properties inside the theming system. In here is where you can modify your text styles. You have different predefined sets of text styles. We have like things like title large, body medium, captions, and others. And this allows you to modify different aspects of each text style, like font weight, font size, and others. So instead, again, of inline styling your text like this, you access the context and the text theme inside it, and then you use the properties from there. Our last stop is at the component theming. So as you may know, the material library offers us a bunch of different widgets we can use in our applications. And each of those widgets has a corresponding theme data class that allows us to customize them. So for our specific widget, we have different theme data classes. And the general recommendation is to use that class instead of actually inline styling your widgets. This way, you avoid conditional logic and ensure consistency throughout your application. So by configuring all of these aspects within your theme data class, you will establish a pretty good cohesive base for your design system that Flutter will automatically apply to your material app. But how do widgets actually resolve the style? And we're going to take a closer look at how the framework does it. So most of material widgets follow a specific hierarchy when it comes to resolving their style. The first check is the parameters. So most widgets in the material library have different style parameters you can use, and this allows for inline overrides and modifications to the inherited theme. An example here, we have an app bar, which I have modified the background color, and we also have a text, which I have modified using the text style class. This is where the theming has the highest priority, which is the inline. Then we got the inherited theme. That this is actually where you get the theme data get applied. So what we saw earlier, this is the point where we get applied. And then lastly, if we have no constructor parameters applied, If we have not override the inherited theme, we will default to the material theme. That it used to give the famous like Flutter blue whitish color palette, but now with material 3 you get like this purplish color palette that is also quite nice. So if you check out like any material widget in the framework, more or less the structure will look like this. You first check the style parameters in the class, and then in the second step you will use the context to access the inherited theme. And then this is actually where also the default theme is injected, because if we haven't override the inherited theme of our widget, basically material will do a filling for us and it will use that style instead. And all of this is great because this is how material widgets figure out how to dress themselves. And this convenience is built in for every material widget because they already hooked up into the theming system. The problem is, what do you do when you want to style and theme your custom widgets? How should you go about this while maintaining a clear and maintainable UI? We will go through a series of examples and we will try to solve them using a similar approach on how material actually solves those issues. Let's first take a quick closer look to this simple widget. It just has a background color and a border radius. At this point, you could decide just to inline style it. So in this case, I inline style the color and the border radius. Since we don't have multiple possible styles for the same widget, this is an okay implementation. But what happens if you now have two styles? This meaning the same component with two visual different variants. You could still argue I can continue to inline style my widgets. And in this case, I have a widget with red background color and a border radius, and then a light red color and a sharp corners, right? But what now if you have like multiple visual variants, like primary, secondary, tertiary, and even more and more? If we follow the same approach and follow the same path, we will end up in chaos because we'll have multiple different styles hard-coded in our different widgets. It will be hard to maintain them and to change them and update them. So if you have distinct visual variants in your widgets, I would recommend to encapsulate style-related properties into a dedicated class. This separates the concerns between the dynamic style of our class, meaning the themable appearance, and other non-stylistic members. And this goes back to what I have been talking about, which is separating the looks from the behavior of our widget. So in this particular case, we have my widget, and I have created another class called my widget style, which holds the background color and the border radius for us. Then I add that class as a style parameter for a widget and use those styles inside that class to style the widget. In this case, background color and border radius. I will also encourage you to use something called theme extensions. You can make your own custom widgets theme part of your theme data. This allows us to extend the theme data with our own custom styles. It's a powerful way to manage consistent and reusable styling throughout our application. Going back to our example, I have created my widget theme that extends the theme extension class. And in this particular case, since we had two different visual variants, the primary and the secondary, I have created two properties called primary style and secondary style. Since we have extended the theme extension class, there is a couple of methods that the framework obligates us to override. In this case, first we have the copy with method. That is a pretty simple method that allows us to, for easy modifications to our class without having to actually create them from scratch. Then the second one, a little bit more important in my opinion, is the lerp method, which before diving into the implementation, let's first try to understand what lerp is. Lerp stands for linear interpolation, and it helps us to build transitions and animations in our widgets. It basically eases the transition between two values over time, using some actual simple math. You have three parameters, which are A, B, and T. A being the starting point, the starting value, B being the endpoint or end value, and T is the position in the timeline of the transition of the animation. When t equals 0, meaning the animation just started, it will just return the a value. And when it's equal to 1, it will return the b value, meaning the animation has finished. And for all the values in between, it will also return values in between a and b. If you take a look at the video we have here, we have a container that transitions between the blue color at the start and ends with a red color. And as you can see in between, it has this smooth transition between different colors till it gets to the correct hex value. And this not only allows us to interpolate between colors and textiles and shapes, it can even interpolate even more complex things and objects like the theme itself. So this is possible because classes are made upon a hierarchy of different components, and those more simple classes can also interpolate themselves. So we can interpolate more complex widgets and classes. A classic example of using the lerp interpolation is when transitioning between light and dark mode in your application, because in that particular case, your whole theme is changing, so you need to have a smooth transition between your widgets so it looks nice to the user. So going back to our example, we are defining the lerp for our theme extension, and we need to lerp in between our own custom style classes. So in order to do that, we also need to create a lerp method in our style class. In our style class, if you recall correctly, we have background color and border radius. So those are the two properties we are going to interpolate. We are using these handy methods from the framework, in this case color.lerp, that allows us to interpolate between the two background colors, and then border radius.lerp that interpolates between two border radius. Then it's just a matter of adding our extension to the actual theme data and making it part of your whole theme in your application. So in this particular case, I instantiate our widget style class 2 times, the first one corresponding to the primary style and the second one corresponding to the secondary style. So we have this difference in style with different background colors and border radius. Then we use the extensions property inside the theme data. And this is actually an iterable of extensions. In this particular case, I'm only setting 1 extensions for the demo, but you can set as many as you want and have your theme data class be very customizable as much as you want. I will also recommend you to use extensions on your theme extensions so they are more easy to access. Basically, you create an extension to call it directly from the theme, the same way you will access the theme data from other material widgets. This makes it so that it's more like a cohesive developer experience. You don't notice like you are using a different API. It's like the same. And then comes with a bonus that you are doing the null check in just one single place instead of having to do the null check in different places around the app. So it centralizes that particular issue. And then we are going to take a similar approach to what we saw with material widgets to actually resolve our style in our own custom widget. The first step is to check the style parameter. But then if we have not supplied our widget with any style parameter, we will basically fall back to a particular style in our theme. So as you can see here, I'm doing theme of context.mywidgetStyle.primary style. So we will be defaulting our widget to the primary style. And then we use the style as normally, accessing the background color and the border radius. This also allows us to inline override our widget style. If we just instantiate it as it is without any parameters, it will fall back to the primary. But if we decide to change it, we can set the style parameter, accessing the theme again, in this case, the secondary style. I will also encourage you to define a copy with method in your own style class. This way, it's much easier to modify your own style parameters without having to remake the whole class. So in this particular instance, what I did is I copy with the primary style and then changed the background color to blue. So we have the primary style with just a slightly modified background color. So think of this as, in this particular case, I only have 2 properties, right? So it doesn't make much sense. But think of it with a class with a lot of style parameters. It will be like a little cumbersome for a developer to create them from scratch. So this is much easier to modify specific values when your style is just a little bit different for that particular case. What now if we want to define different values for our style properties for our different states in our widgets? Let's say we want to implement something like this. The same component, but as you can see, is transitioning into a new style whenever we enter the press state. So your first approach could be just to repeat the same variables and add a prefix to it. In this case, we have background color and press background color, and then we have border radius and press border radius. This approach may seem fine at first. The problem is, what if your widgets depends on multiple states and has multiple properties that are changing based of those states? You will end up with an API like this, which is a lot. You have multiple repeater properties, so it will be difficult to maintain over time. Especially if you're adding more style properties to your widget, it will become like a long list of properties. So instead of doing that, there is a solution for it, which is actually made by the Flutter team, which is instead of using static values in our widget style properties, we will use functions. These functions will depend on our widget state and will return a specific value based on it. So in order to understand what those functions are, let's first try to understand what the widget state is. So widget state is just an interactive state recognized by the material design library, but it's actually not limited to it. Some Cupertino components also use the widget states. In this case, in the Flutter framework, it's implemented as a simple enum, and it has different states like press, hover, focus, disable, and others. Then the function we've been talking about to resolve our style value depending on our widget states is actually a class in the framework called widget state property. And as you can see here, it has the final resolve method, which receives a set of widget states and returns a value, which is going to be the style value. This allows for properties to resolve into different values based on our widget state, styling our widget to visually change with the user's interactions and state changes. So, of course, we will need to update our style class. Instead of having background color of type color and border radius of type border radius, we now have background color be a widget state property, which is basically this function that resolves into a specific value based on states, and the same goes for border radius. This, of course, solution is much better than the previous one we saw because we don't pollute our class with multiple members like disable, press, hover, whatever. And it also, and also important, it centralizes the stylistic logic, meaning your logic between transitioning different values on your style will be independent from your widget. It will not be polluting your build method. We also need to modify a little bit our lerp method. We need to call widget state property .lerp this time around to lerp in between two widget state properties. And since widget state property is of generic type, we also need to tell him how to interpolate those style values. In this case, again, color.lerp and border radius.lerp. And then we need to tell our style class how it is going to actually resolve our style values depending on our state. For that, we use a function called resolve_widths that actually allows us to define a function which receives a set of states, and then we need to return a value. In this particular case, you see here, I check for contains widget state.press, which is what we saw in the example. We want to change the style based on the press state. So we return different colors and different border radius based on that. This setup obviously allows us to solve the problem we had earlier, which is to transition between a particular style when the widget is pressed. But it also easily scales for having different widget state properties, like selected, press, or disable, or whatever other style properties you want to have. There is also an alternative, a newer alternative to using the resolve_width method that is called fromMap, that instead of defining a function, basically you define a map that the keys will be the widget states and the values will be the actual, in this case, colors and border radius of the style value. So it's much easier to implement, and also as a code reviewer to read the code and actually understand what it's doing. It's like more simple. We also need a way to track our widget states inside our own widget solution. There's multiple ways to go about this. What I did is what I consider the simpler one, which is having a set of widget states in our widget. I initialize them as empty, and then as the user presses the button down, I add the press state, and then when it stops pressing it, meaning a tap up has happened, I remove the press state. And then, importantly, we need to call the resolve method we saw earlier from our widget state properties. So those can resolve each style against our widget state in that particular moment in time. And of course, we need to call set state, so our widget gets revealed every time. In this case, our user interacts with the widget and goes into the press state or removes it. Then there are other classes that I call specific widget state property classes, which are basically classes that are widget state properties that implement a particular style class. In this case, and the most common one, is the widget state color, which extends color and implements widget state property. This class is it is created so that you can either set a color to your particular property, or you can set a function. So you can have it both ways. And what I mean by this is this. Let's say we go back to our widget style and remove the widget state property altogether and continue having a background color of type color. We can still be defining our background color as a from map, or we can just set a static background color. So you can have both implementations in the same one. The only thing that changes is that in our widget, we need to call a new method called resolves as. With what it does is first checks whether your property is actually a widget state property. If it is, it then will call the resolves method from that widget state property. And if it is not, this means it's just a static value, meaning just a color. So it will just return that. This API is great because it allows us developers to have a lot of flexibility on our style classes, but it has some things that could be improved. The first one being there are multiple widget state property classes like widget state mouse cursor, widget state color, widget state border radius, widget state textile, and others. And given the fact that implementations are pretty similar among those, the framework has copy-pasted a lot of the implementation, and it made mistakes much more likely to happen. For example, in this particular case, it says that widget state mouse cursor will be used to resolve the color in our given states, and we're talking about the mouse cursor, so nothing to do with colors. And this problem gets repeated across multiple and multiple classes. These are just some examples. So this is the first issue with this API. The documentation is incorrect. The second problem is that it's actually an unsafe type, because even though your widget, in this case, it has a property color, and you can assign it a static color value, in this case, red color, or you can also assign it a function which resolves our style values based on widget states. It will not work for the second implementation, because as you can see here in the box decoration, I'm just setting color, and I'm never calling resolves as that we should be calling. So this basically will throw an error. It will not work. In order for the implementation to be able to support both modalities, will be to call resolves as that we saw earlier. And the funny thing is that this is acknowledged by the framework, but the only solution they have right now is to document. In this particular case, it says it should only be used with widgets that document support for widget state color, and says throws an error if used in a normal color. Another example, it says if the period color is of type widget state color, then the effective background color changes based on state. So you need to rely on documentation to avoid errors in your implementation. And this is very tricky because documentation is not always up to date. So it's not a type safe class. And lastly, An obvious one is that it has multiple types around it. You have widget state color, widget state textile, widget state border side, and you have to memorize all these APIs and know that they exist. And also the problem is that the Flutter team hasn't catch up yet to all the different types of classes we can have. So you end up in a situation where for some styles you have this and for others you don't. So there is actually an ongoing proposal right now on the Flutter repo, which is called API proposal, which is state property or, which aims to solve all of those issues. This class with will be only one class. I will replace all the other class that we saw earlier. So this will enable, obviously, eliminate the problem with errors in the documentation because it will be just one class, no copy paste. It will no longer be an unsafe type because you will have to use this specific class and not just have a class that extends color or textile or whatever. And you will no longer have multiple APIs to interact with. It will be just one class. So it more or less eliminates all the problems. The API proposal is much more complex, so I recommend you go and check it out. It's pretty good, and you can give it some love there. Lastly, I want to go back to an example of another widget called expansion tile. You see here that it changes background color, the textile, and the icon based on a state. This code could be collapsed or expanded state. And you might be thinking, Maury, we already talked about this. You already told us how you can style your widget based on a widget state. And you will be right. The problem is there is no widget state that represents the collapsed or expanded state. So you can also be thinking, how does the actual expansion tile in the framework resolve the problem? Well, it doesn't. It goes back to what we saw earlier, which is having a confused API where you have background color, collapsed background color, icon color, collapsed icon color, and so on. And this is not an isolated problem. It also happens with other widgets API, like slider or floating action button. And these are just to give some examples. There are much more that need to be updated. The fortunate thing is that the Flutter team is slowly migrating all of these APIs to start using widget state properties and widget states, so we don't have to deal with that problem. But some remain there. So the only solution I could find at the moment, if you want to extend your widget state, is basically to copy paste the whole API in your own app and add your expanded or collapsed state there, but whatever state you want to add, right? It's not that complicated, but I personally think there should be a much easier solution for this. So basically, what I've been trying to work on, but I still haven't had the time to upload it, is to propose an API change to the widget state. In this particular case, we will be introducing a new interface in between the widget state and the rest of the implementation. In this case, I just call it raw widget state, could be whatever name. Then the widget state class, which is from the framework, will continue to be the same. It will have the hover, the press, whatever values it already has on the framework. The only thing that will change is that it will extend raw widget state. The good thing about this change is that it will not impact any of your current applications. You will just continue to use widget state as normally if you already are doing so. But the good thing is that it will allow you to have your own enum in your own class, in your own app. And in this particular case, for my solution, for my expansion tile, I would like to extend it to have a collapse state. So yeah, this is just my thoughts on it and how it could be a little bit improved, but it already has a lot of flexibility, and I think you could enjoy using it. Then the only thing that is missing is just defining our widget state property using that new state that we added. This is just to show you that basically the API remains the same with the change. You still call widget state property results with, and in the contains, instead of using widget state from the framework, you will use your own class. In this case that I call my widget state and collapse. and change the color based on that. So before closing, I just want to give some last thoughts. I know the theming system might be a little bit daunting at first, but I truly encourage you to experiment with it, try to leverage it, and see its power. I think it can be an incredible tool for any Flutter developer. My recommendation will be to start messing around with theme data and the color scheme and the typography and the material side of the theme, and trying to understand how the framework actually resolve all of these problems and understand the powerful mechanism you have at your disposal. Then, when building your own custom widgets, I would try to strive to mimic that same behavior in your own implementation. Trust me, working on a Flutter project with a really robust theming system genuinely elevates your daily developer experience. Not only does it simplify the separation of concerns between allowing you to focus on behavior and or looks, but also your custom widgets will feel like they integrate seamlessly with the actual theme class in the Flutter app. And this will be much more intuitive to use and to style your widgets. Thank you. I think we have a couple of minutes. Not sure if anyone has any questions. Yeah. Yeah, I can share them with you after. Yeah, yeah. I will also probably publish them around like LinkedIn or something, so you can follow me to check on them. Yeah. That's great. Well, thanks everyone. Enjoy the rest of the conference.